This is a short series of presentations to assist paraglider and hang glider pilots who are studying for their BHPA pilot rating exams. This series is on flight theory and instruments. We now need to talk about the force vectors applied to a glider. Several of the various forces that are working on a glider in flight can be ascribed different vectors to summarize the direction and degree of their force. The downward force of gravity is shown by the vector labelled W for weight in this diagram. It is gravitational pull that applies the forces to the glider wing, and some of the downward motion is then converted into forward energy, shown in the diagram as V for velocity. The airspeed that is developed by the velocity of the wing generates lift, shown here by the vector L, which pulls the glider both upwards and forwards. Slowing the aircraft at all times is a vector called drag, illustrated by the force vector in the diagram labelled D. Balancing all these various forces is a vector called the resultant force. This is a function of the size of the force of lift and the size of the force of drag. This force, labelled R, always works on the centre of pressure for the aerofoil, while the force of gravity, W, always works through the centre of gravity. You may recall this diagram from an earlier section of the flight theory series. This is where we described how the centre of pressure, which anchors the resultant between the lift vector and the drag vector, moves independently from the centre of gravity for any aerofoil. Moving the centre of pressure forward using wing controls causes the aerofoil to pitch back and to slow down. Allowing the centre of pressure to move backwards relative to the centre of gravity causes the wing to pitch forward and to speed up. Now let's look in more detail at the drag vector, its type, causes, and what its effect is on airspeed. It's important to understand the different types of drag that develop as a result of an aircraft moving through the air. It's probably true to say that most of the performance improvements that have taken place as a result of design changes in our free flight wings have been due to reductions in drag. Broadly, there are three types of drag to consider. Induced drag is an inevitable consequence of the creation of lift. At the wingtips of the airfoil, small vortices are developed as the air slides away from the undersurface of the wing, but is deflected inward over the upper surface. These small areas of turbulence exert a drag on the aerofoil, especially at lower airspeeds. The upturned tips on fixed-wing passenger aircraft are an attempt to minimize induced drags at the tips of the wing. Interestingly, the amount of lift-induced drag decreases as airspeed increases. Parasitic drag is a combination of two subtypes, form drag and friction drag. Parasitic drag increases as airspeed rises. Friction drag is the capillary adherence of the air to the surface it passes over. Form drag can be reduced by paying attention to aerodynamics. Examples would include streamlining of uprights on hang gliders or addition of tail fairings to paragliding harnesses. Finally, there is profile drag. This is where air separates from the surface over which it's flowing and creates its own turbulence wake. This happens at slow speeds on the upper surface of an airfoil and can stop the wing flying in stall conditions. The graphic towards the top right of this slide shows the relationship between airspeed and drag and how there is a sweet spot in respect of drag at a certain speed. The three types of drag, induced, profile, and parasitic drag, act together to develop a curve of overall drag that changes according to airspeed. We need to be very clear about the difference between our airspeed and our ground speed. In considering our ground speed, it is important to understand the relationship between the wind speed and direction and the airspeed of your aircraft. In nil wind conditions, the glider's ground speed will match the glider's airspeed. However, in any headwind, the glider's ground speed is reduced by the wind speed into which you're heading. Similarly, if you're gliding downwind, the wind speed is added to your airspeed to yield the ground speed of the aircraft.